All right, so we're going to finish the properties and conditions for kites and trapezoids today. Pay attention. Do not do this. We were on page 82 yesterday. We had a big blank space at the bottom. We're going to come back and put something there, but not yet. So leave this blank. We're on page 83. You're going to need to tear out page 473, page 476, page 477. We're cutting a lot out. You also need a piece of notebook paper. I gotta go get a piece myself. Get a piece of notebook paper as well. So, all of these pages and a piece of notebook paper. It's not a lot of writing at all, but it is a lot of information. So thankfully we're not going to have to write it like we did with the others, but okay. We're going to have to be careful. Do not get rid of any of those 3 pages until I tell you we're done, because we're going to be gluing in a lot. Okay, from 473. Let me find my scissors. From 473, you need a trapezoid and the pictures. Glue that in right here. From the back of that, 474, you need the 3 Isosceles trapezoid theorems. Glue that in here. Okay. Then, take your piece of notebook paper. These notes, I want the trapezoid notes to all be on the same page. The problem is they are too long to all be on the same page. So you are going to take your piece of paper and we're going to make this page longer. You have a piece of notebook paper. You are cutting off the holes on the side there and gluing it right below what we just put in. Okay, I'm going to glue it right here. The reason I'm doing that is so that I've got all this extra page of space. I'll cut off anything I don't use later. But go ahead and glue that in down here to make the notebook longer. We will cut off anything we don't need, but you don't have enough space. You know how small I write. You don't have enough space whether you write small or not. I think I got the glue a little bit too far down. It's okay. So it'll flip open. Okay. All right. So you got your piece of notebook paper glued in. So we can keep going. All right. Now, from page 476, you need numbers 8 and 9 and the explained 4. Okay, so 8 and 9 and explain 4. That'll be some on your notebook paper. Still not done. We're still going. Underneath that, you're going to glue in number 10 from page 477. Now, you're going to need to skip a couple lines first. Let's skip about 1, 2, 3 lines. Glue that in right here, number 10. Okay, and we actually can cut off this. We don't need this now. We're going to do the work over here. So we cut off the extra space. Okay. Now, one more thing before we're done. So that's all of page 83. Pause the video, go back, anything you need, because we're going to start up here in a minute. On this page, we're going to glue something from 478. And that's this little Venn diagram. Okay. So I'm going to go ahead and cut out the Venn diagram and glue it in, and then we'll come back and talk about it. So that's from 478. Then we have cut out every single thing, and you can throw away all the scraps. Okay, and this does probably kind of hang off a little bit. That's fine, we'll go fold it up too. Glue this in right there. We will fold it up when we're done. This will be a whole page of just folding stuff. All right, so we're going to go to page 83, work on this stuff, then we'll come back. So let's talk about a trapezoid. All right, now there's more than one definition of a trapezoid. We're going to be looking at what this book says a trapezoid is. However, in the world of mathematics, sometimes there's a different definition of a trapezoid. So, a trapezoid is a quadrilateral with at least one pair of parallel sides. This one says at least one, which means a parallelogram with two sets of parallel sides would be considered a trapezoid with this definition. At least one. However, there are other definitions that say exactly one. If your definition says exactly one pair of parallel lines, then a parallelogram cannot be a trapezoid. Okay? So it's possible that it's either a trapezoid is a parallelogram can be a trapezoid with this definition, but if somebody uses the word exactly one pair, it cannot be a trapezoid. You'll have to notice what this is using. Since this is the definition in this book, a parallelogram is a trapezoid. But if it was another definition, it would not be. All right, so the pair of parallel sides of the trapezoid, or either pair of parallel sides, if the trapezoid is a parallelogram, are called the bases of the trapezoid. The other two sides are called the legs of the trapezoid. A trapezoid has two pairs of base angles. Each pair consists of two angles adjacent to one of the bases. An isosceles trapezoid is one in which the legs are congruent but not parallel. That's an isosceles trapezoid. This is just a regular trapezoid. Here are theorems for an isosceles trapezoid. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. These are congruent because they are the base angles, but these are congruent as well. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So if you know that it has congruent base angles, then it's isosceles. A trapezoid is isosceles if and only if its diagonals are congruent. So in a trapezoid, the diagonals are congruent to each other. Okay? It doesn't say they bisect or anything. but they are, that they're, bisect. They are congruent to each other. Let's talk about 8 and 9. Number 8. Let me move this so we can see it a little better. An isosceles trapezoid PQRS, in isosceles trapezoid PQRS, use the same side interior angles postulate to find measure of angle R. Okay, here's what it means by that. In an isosceles trapezoid, we know these two are congruent. So this is 77 degrees. We know these two are congruent. We need to find R. It says use the same side interior angles postulate. Here's what that means. Since I have two parallel sides, these two are same side interior. So same side interior is supplementary. I simply am going to have to do 180 minus 77, which is 103. So the measure of angle R is 103 degrees. Okay. Number 9. JL, this diagonal, is 3y plus 6. KM, this diagonal, is 22 minus y. Determine the value of y so that trapezoid JKLM is isosceles. Well, right here. A trapezoid is isosceles if and only if its diagonals are congruent. So congruent, we're going to set them equal to each other. So once you set them equal to each other, pause the video and solve it. Find what y needs to be. Okay, I'm going to move this over here. So I'm going to get 4y plus 6 equals 22. Move the 6 over. 4y equals 16. Divide by 4, y equals 4. Notice it said solve for y. Always pay attention to what you're solving for. More than likely, you always do you will always be solving things for an isosceles trapezoid instead of another type of trapezoid, like just a regular one. This, where they add up to 180, by the way, is true of any type of trapezoid. This piece, though, is the only thing that's separate where they are equal. And it's not true of another trapezoid. All right, let's talk about the trapezoid mid-segment theorem. Okay. The mid-segment of a trapezoid, kind of like the mid-segment of a triangle, is the segment whose endpoints are the midpoints of the legs. So we've got this going on right here, and we're going to label this one. So let's label it A, B, C, D. And let's label this X and Y. Those are the mid-segments, the midpoints of those sides. There is a trapezoid mid-segment theorem. The little star beside this, you will use this quite a bit. The trapezoid mid-segment theorem says we've got X, Y is going to be parallel to both BC and AD. But the thing that you use the most is the fact that the mid-segment is equal to 1/2 of the two bases added together, BC plus AD. Basically what it's saying, my video froze, so let me give you a minute. Let's fix that, sorry. So these two are parallel to this one, so this one is also parallel. And what it's saying is this mid-segment here is equal to the average of these two. That's what it's actually saying, okay? So let's look at number 10 and solve it. Number 10, in trapezoid PQRS, PQ, right here, is equal to 2RS. So we're supposed to find XY. Well, first of all, we need RS to find XY, okay? I have to zoom in so we can see it better. And move my notebook just a little bit. Okay, so we have to find XY. In order to find XY, we're going to have to find RS first. So PQ, which is 16.8, is actually equal to 2 RS's. So divide by 2, and RS is 8.4. 8.4. Now, what we're actually trying to do, though, is find xy. And xy is the sum of PQ and RS divided by 2 or multiplied by half. Same process there. So xy is equal to 1/2 8.4 plus 16.8. You can't see that. There you go. So typing that in, I get xy is equal to 12.6. 12.6. So the midsegment is the average of these two numbers. Okay. Once you have that, go ahead and fold that up. Got it in our notebook like this now. It looks a little strange, but that's okay. Notebooks look like this. We can flip it down we need to. Let's summarize all of the things we have learned. All of the triangle congruences, not triangle congruences, all of the quadrilaterals that we have learned so far. All right, first of all, every single one of these is a quadrilateral. Every one of them. Then, for the biggest part here, at least one pair of parallel sides is a trapezoid. Based on this definition, everything inside here is a trapezoid. If the definition was exactly one, you would have a extra circle over here that said trapezoid, okay? Inside of that, two pairs of parallel sides is a parallelogram. Inside of that, you have a rectangle with 4 right angles. You have a rhombus with 4 congruent sides, and you have a square, which is both. Based on this definition, a square is a trapezoid, a rectangle is a trapezoid, a rhombus is a trapezoid. Then over here all by itself is a kite. It's a quadrilateral, but it is never anything else. Well, a polygon, but a polygon is just any shape. Okay? Go ahead and finish the assignment and the little properties table.